So derivative of tan inverse of root 1 plus x square minus 1 by x with respect to tan inverse x we need to calculate. Just for our convenience, if you treat this function as some y and this function as some z, then our task is to find dy by dz. Okay, if you take this as y and that function as z, the question is about finding derivative of y with respect to z. So dy by dz we need to calculate. For that, first calculate dy by dx because y is there in terms of x, and calculate dz by dx because z is also there in terms of x. But just for our convenience, I am trying to convert the problem in terms of theta because tan inverse is involved, right? Direct differentiation maybe get complicated bit. So take x is equals to tan theta. If you take x is equals to tan theta, what will happen? If you take x is equals to tan theta, then y is equals to tan inverse of root of 1 plus x square. X is tan theta, tan square theta plus 1 secant square theta, root of secant square theta is secant theta minus 1 by tan theta. Okay, if x is tan theta, y is this tan inverse secant theta minus 1 by tan theta. And now try to simplify this. Secant theta 1 by cos tan theta sin by cos. So this is nothing but tan inverse of 1 minus cos theta divided by sin theta. So you just try to simplify this part. 1 minus cos theta is 2 sin square theta by 2, whereas this sin theta is 2 sin theta by 2 into cos theta by 2. So tan inverse of 2 sin square theta by 2 is numerator, whereas this denominator is 2 sin theta by 2 into cos theta by 2. So 2 and 2 gets cancelled. Sin theta by 2 gets cancelled. Sin theta by 2 divided by cos theta by 2 is tan theta by 2. Tan inverse of tan theta by 2 is theta by 2. So first simplify, then apply differentiation. As a part of simplification, since the problem involves with this tan inverse, you just let x is equals to tan theta. If x is tan theta, y is theta by 2. Now try to solve, try to simplify z. Okay, and z. See, x is equals to tan theta and z is directly tan inverse of x, so which is nothing but tan inverse of tan theta, and so this is directly theta, just theta. And now just look here. Now our task is to find dy by dz, as I said, that is equals to derivative of theta by 2 with respect to theta. Y is theta by 2, z is theta. So derivative of theta by 2 with respect to theta is nothing but 1 by 2. Finally, dy by dz is what? 1 by 2. Derivative of the first function with respect to the second function is 1 by 2. There is this problem. Okay. Just to simply, for our convenience, I took y, z as well theta. Okay. Have a look.